Okay, let's go over practice 8.4. I have the graph for the first directions are for us to determine whether or not the functions are even, odd, or neither. An even function is symmetric around the y-axis. Around y-axis. And an odd function is when we have 180-degree rotational symmetry around the origin. Okay, now, and neither has neither. The very first one, 4 to the x minus 1, actually looks like this. This function just goes along slowly and then starts going upwards. I can't reflect it over the y-axis. And if I were to turn it 180 degrees, what I would see is just that it would come back around and might wind up in this quadrant. So I'm going to say neither. Leave it right there. Thank you. For number 1, it's in neither. Now, let me go in. I've got my turn off my y1. I loaded these functions up early so I could just switch between them. There is my number 2, 2x minus 5. This one doesn't look like it's symmetric around the y-axis at all. If I were to flip it, this top of this would come here, the bottom would come here. And also if I were to turn this, I think this would, we'd see this in another one, what would happen here is it would wind up turning and being over on this side of the the axis. So this one would be neither as well. And then let's go look at the third one. 2x squared plus 5. This one looks like it's going to be even because it is sitting, it's a skinny parabola compared to the parent, and its vertex just moved up the y-axis 5, so that makes it even. I could fold it on the y-axis and it would be a mirror image. Going along with the same idea, number 4, I'm going to say this function is also even. It's got a line of symmetry at the y-axis. And then looking at this function, I don't think there's anything. I'm going to just test it out real quick with my patty paper. If I were to turn this 180, there's 90, there's 180, it winds up down here. So that one is going to be neither as well. Now, even and odd functions, that was one of the concepts in section 8.4. Jeez Louise, doing too many problems today. One of the others was, let's look at these parabolas in what we call vertex form. Vertex form tells us that vertex form looks like this. We've got y equals some value a that still tells us if it opens up or down and if it's narrow or wide, x minus h squared plus k. And then we can go grab out the h and the k as the vertex. The vertex here, x minus what number would be x plus 2? This is going to be x minus negative 2. And then since nothing's added out here, we assume that the y value of the vertex is negative 2. We also have to write down the axis of symmetry. That's just the equation of the vertical line through x equals negative 2. Vertex, axis of symmetry. Same idea for number 7. The vertex is at 3, and it's like there's a plus 0 out here. That puts the axis of symmetry as the vertical line, x equals 3. Make sure your axis of symmetry is in the equation of a vertical line, x equals. Number 8, we have the vertex is sitting at x minus negative 7, must have been there, plus 0. The axis of symmetry for this would be the equation x equals negative 7, that vertical line equation. Now, when we go on to numbers 9, 10, and 11, you have to graph the function, and I had you graph the parent function as well in order to make your comparisons. What I've done on my paper, just to get the ball rolling here, is I've gone and taken, and I have the parent function on each of mine. Find your number 9. You guys have done this all already in class. This is just reviewing it. So if it seems like it's going quickly, it is going quickly because all we're doing is looking back at everything you should have had finished already. I made a table of values right out of my calculator. I grabbed this just to save some time. When x was negative 3, y was positive 8. When x is negative 2, y is positive 2. When x is negative 1, y is 0. 0 and 2, 1 and 8. So what I see here is, and I can talk about it in terms of all the parts of, so the comparison has to happen like this. The 2 made the parabola narrower than the parent, and the x plus 1, that plus 1 inside, gave us a horizontal translation left 1. Horizontal translation left 1. Be sure that you're talking about all the parts of the equation and how it changes the parent function. into what the new function is. Same idea with number 10. I've got the table of values I set up for number 10. I'm guessing this is going to be narrow and probably to the right too. Let's graph it and see. I only had 3 values in my table to use, 1 and 3, 2 and 0, 3 and 3. Sure enough, this parabola got narrower and moved to the right too, like I expected. The 3 made the parabola narrower, and this minus 2 moved it as a horizontal translation right too. Horizontal translation right too. Cool. Now, moving on to number 11. I'm expecting this is going to make it fatter and probably move left 6. Let's see what I've got here. Negative 10 and 4. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 4. Negative 8 goes up to 1. Negative 6 is sitting at, 1, 2, 3, 4, 5. Negative 6, 0. Negative 4, 1, negative 2, 4. You know, I just want to say about this one, now that I'm looking at this table, the reason I went every 2 x values, if I'm remembering right, is in the table, like at negative 9, I had some number that was maybe like 2.75 or something, and I didn't want to have to estimate to graph, so I took all the integer pairs. And what I thought was correct, this made the parabola wider to 1/4, and this plus 6 gave me a horizontal translation left 6. Horizontal translation left 6. So those are the types of things that you'll be doing on your quiz and on your test over this section. Make sure you talk about each part. I've got all my 9, 10, and 11 done on my graph paper. Find the vertex and axis of symmetry. Well, now we're in the same position we were up through 6 through 8. We're looking just to pull the vertex out of the equation. It must have been x minus negative 3. And then on the outside, this negative 2 gives me the y value of the vertex. Our axis of symmetry is x equals negative 3. I remember somebody in class calling this light work. Vertex is at positive 2, 5. That puts the axis of symmetry at x equals 2. And again, I'm doing this quickly, but this is not the first time you're looking at it. Just checking in what you have, negative 5 and negative 4. And then this is published, so if you need to take more time with it on your own, you can go home and check out my YouTube page and pause this and work through whatever you need to. There we go. Last one was negative 5, negative 4 for the vertex. Axis of symmetry, x equals negative 5. What do we have left here? A couple more graphs. I thought I had a few more on the back of my paper. Same idea. We're just in vertex form. When I take a look at 15, there's my parent already there. I've got some values in the table. 1, 1, 2, 3, 4, 5, 6. At 2, I go up to 3. At 3, I go up to 2. At 4, I go to 3. At 5, I'm back up to 6. So in this, I didn't see any flipping or any wider or narrower. There's no value of a here any different than the 1 that we expect with the parent. But it looks to me like this negative 3 made us go horizontal translation right 3. Horizontal translation right 3. Took it this way, and then that plus 2, just set them on a desk right there. That plus 2 is going to give me a vertical translation up 2. Thank you. All right, number 16. Okay, let's see. To the right 3, up 2. Got that one. Number 16. I see. I think 3 things are going to happen here. It's going to flip over the x-axis. This plus 2 inside is going to move it left 2, and I'm guessing the vertex is going to go down 4 because of this. So first things first, let me plot this. Negative 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6, 7, 8. Negative 3 goes down to negative 5. Negative 2 goes down to negative 4. Negative 1 goes down to negative 5. 0 goes down to negative 8. Sure enough, what I expected to see is what's happening here. We have a reflection over the x-axis from the negative, reflection over x-axis from the negative. Then we have a Horizontal translation to the left 2. Horizontal translation left 2. And then this -4 gave me a vertical translation down 4. Vertical translation down 4. Cool. Now, that takes us through 15 and 16. In 1 second here, we're on to rewriting. Cool, I'll come over. All right, now, last but not least, let's do 2 more problems, 17 and 18. Rewrite the quadratic function in vertex form. So we have to take it to y equals, or f of x equals a times x minus h squared plus k. And what we know is standard form a stays the same. So for the a value on this one, I'm going to have to use 2. When I look over at 18, my a value is 3. Those guys stay the same. Now, I'm going to use my calculator. I think I had these in here. I do. 2x squared plus 4x minus 1. I just want to go graph this and see if I can't find the vertex for my calculator. It looks like the vertex is at 1 and negative something. And it sure is. Oh, I was wrong. -1, -3. If the vertex is at -1, -3, then I will write my equation in vertex form as y equals, my a value is 2, x minus -1, which is going to make x plus 1, that's squared, with -3 on the outside. Now, when I go and look at the next graph for our last one here, 3x squared minus 12x plus 4. When I go look at the graph, it looks like the vertex is maybe underneath 2. I'm going to go second table and see what's going on at 2. And sure enough, the vertex is sitting at 2 and -8. And so what I can do then, and this is in f of x function notation, f of x equals, my a value is 3, x minus that 2 squared, minus 8 on the outside, and there is our vertex form of the same function. We'll talk about and play around with number 19 in class. It was a bonus question. It's worthwhile for us to look at together before we take a quiz or a test. Good luck.